Good morning friends. In this video I will teach you the behavior of simple DC parallel circuit. So first we have to draw the simple parallel circuit. So first I have to select the source cell, DC cell. I have to select like this. I need a 3 resistor. I take a 3 resistor. So I am going to connect these 3 resistor in parallel connection. So I want to rotate the resistor in vertical position. So in the parallel circuit, each branch the current will be differ, but the voltage across each element will be the same. So whatever the voltage I am giving to the source, whatever the voltage I set in the cell, the same voltage across the 10K, same voltage across R2, same voltage across R3. In the parallel circuit, the voltage will be same. The current will be differ. The current through R1 is different. The current through R2 is different. The current through R3 is different. The sum of these 3 currents, the sum of R1 current, R2 current, R3 current will be equal to the total current. Whatever the current supplied by the battery, that is the total current. That total current equal sum of current through R1, sum of current through R2, current through R3. Okay. This is the characteristics of the parallel circuit. So we have to measure the current as well as the voltage. I told you the voltage across battery, the voltage across R1, the voltage across R2, the voltage across R3, all will be same. The current through R1 is different according to the R1 resistance. The current through R2 is different according to the R2 resistance, likewise R3 also. So we have to measure the each branch current, so that we have to connect one ammeter series with R1, another ammeter series with R2, another ammeter series with R3. Okay, so we need a DC ammeter and voltmeter. We go to the instrument. First we have to select the voltmeter. So I want to measure the voltage across input source. So that one voltmeter I connected here. Another voltmeter I want to measure across R1. Another voltage I want to measure across R2. Another voltage I want to measure across R3. See, kindly remember all the voltage will be same. So next I want to measure the current. So I select the DC ammeter. One ammeter seriously connect with the R1 branch. Another one ammeter seriously connect with the R2 branch. Another one ammeter seriously connect with the R3 branch. So this is I1 current, this is I2 current, this is I3 currents. Each ammeter seriously connected with that branch resistance. One more ammeter is required, that is to measure the total current supplied by the source. So I need one common ground, so that I select one common ground. So this is a parallel circuit. We have to connect all the 3 resistor and input source, that is cell, all connected in parallel connection. Parallel connection means same end are connected together. See, same end are. Otherwise we can consider the ending end. All the ending end are connected together. Starting ends are connected together. In such a way we are doing the connection is called it as a parallel connection. See, all 3 resistors, the second end is connected in the ground. Voltmeter should connected always parallel in the circuit, so that all the voltmeter second terminal connected in the ground. So here I use the 4 voltmeter, all the 4 voltmeter negative terminal connected with the ground connection. Now we have to connect the cell plus connected to the ammeter plus. Okay, ammeter connected should connected in series. Series connection means starting and connected with one terminal, ending and connected with another starting terminal. Okay, so this is a ammeter to measure the total current. So this ammeter negative is connected with the first ohm ammeter plus. The ammeter minus, first ohm ammeter minus is connected with the R1 resistor. This ammeter, this R1 connected in series, but this series combination parallelly connected with the battery. So this this ammeter is a second ohm ammeter, though this plus should connected with the ammeter which is measure the total current. That negative terminal we have to connect. Why? Because the R2 branch also connected in parallel, so that all the positive terminal connected with the one common. Say how we are all the negative terminal connected in the ground, likewise all the positive terminal connected with the positive of the battery. The battery is series with this ammeter, so that we have to connect all the plus terminal of each ohm connected with the negative terminal of the ammeter which is measure the total current. So this is the ammeter which measure the third ohm current, so that positive terminal also should connected with the negative terminal of the total current measured ammeter. So the negative terminal of third ammeter connected with the R3 one end. See, this ammeter and R1 connected in series, that is the first parallel ohm. This ammeter and R2 connected in series, that is the second parallel ohm. This ammeter and R3 connected in series, that is the third parallel ohm. Each parallel ohm we have to measure the voltage across each resistance. So this voltmeter connected across the R1. That means the plus terminal connected with the R1 plus, the minus terminal connected with the R1 minus. Likewise ohm 2, likewise ohm 3. We should not connect this voltmeter plus with here. If we do so, the drop across ammeter and R1 will measure by the voltmeter. Small internal resistance present in the ammeter also. Because of that internal resistance, some of the voltage developed across the ammeter also. If you are connecting this terminal and this terminal, then we can measure the drop across ammeter as well as R1. But that is not our expected drop. The expected drop is across the resistance only. That's why I connect the voltmeter across R1, R2, R3 only. Okay. So this is total voltage I have to measure. So I want to measure the voltage across battery. So I have to connect like this. Now the entire connection is over. Now I want to change the small values in the resistance. I make the first resistance is 2 ohm. I set the value for R2 resistance is 4 ohm. For R3 I make it 8 ohm. So any value we can fix. In order to simply understand, I select the small values. So I select here the 80 voltage. That also for the answer will be the real number. That's why I make it not integer value. I want to make integer. That's why I make the 80 volt. Any voltage you can set. For I want to make integer value, I make it 80 volt. So I set the input voltage is 80 volt. The first ohm 2 ohm, second ohm 4 ohm, third ohm 8 ohm. Okay. What will be the total resistance? The total resistance 1 divided by RT equal to 1 by R1, 1 by R2, 1 by R3. Likewise, we have to measure the equivalent resistance in the parallel circuit. What will be the total voltage? Total voltage Vt equal to V1 equal to V2 equal to V3. The voltage across the parallel circuit will be same. The total current IT equal to I1 plus I2 plus I3. So this is the total current. This total current equal to the sum of this current and this current. This current, let us take I1 plus I2 plus I3 equal to total current. So all the voltmeter will shows the same voltage 80 volt. Now we have to check the response. I just run the simulation, then I pass the simulation. Now you check the voltage across